This part is nothing but just talk, so if you want to skip through it, feel free. We're just going to kind of go into a little bit of detail as far as the layout of my system on paper and some of the calculations and things I consider as far as sizing various parts. If you like a list of the major components making up my project, check out the affiliate link below in the description section. Just to recap the configuration we have right now, we actually have solar panels. We have two solar panels that are generating 200 watts of power. The panels is connected to a charger controller with a fuse. The other connection is associated with the charger connection. In addition to the solar panels, the plus and minus, you also have a plus and minus cable going from the charger to my battery, my 12 volt deep cell battery. Now I show one battery here, but more than likely I'm going to have 2 to 3 batteries. Also coming off of charger will be a monitor for monitoring battery temperature. Also coming off the battery will be a plus and a minus with a fuse going to my inverter. Now feeding off my inverter will be my loads, and my loads are going to consist primarily of lights, LED, TV, and miscellaneous items. Included in this miscellaneous for next winter consideration may be a infrared heater. This is optional. The current configuration that we're working on right now may not carry this additional load of the heater, but for right now my primary purpose is to feed my lights, my LED lights, and my LED TV. Again, solar panels, charger controller, 12 volt battery, and 12 volt power inverter. What I'm also considering, and I haven't fully decided to implement it yet, will be a ATS, automatic transfer switch. And what that switch will enable me to do is to feed power off of my inverter and switch as necessary automatically to my grid or house power. This will automatically switch between solar and my house grid. To come up with this configuration, we're going to have to come back and do some calculations as far as sizing, and that's the next step that we're going to go into, the actual sizing. My load, I'm going to consider, will be an LED lights, and that consists of 8 shop lights rated at 20 watts each, which equals 160 watts. Also, I'm going to have an LED TV, and my LED TV is going to be one 32-inch requiring roughly 25 watts of power. This gives me a total of 185 watts. So I'm estimating my loads are going to be LED lights at 160 watts, LED TV at 25 watts, and these are the watts. Now to come up with watt hours, I'm usually in my workshop for 4 hours, so my time equals 4 hours. So if I multiply 4 hours times the 185 watts, I come up with 740 watt hours. Just to kind of recap my equation, the equation that I'm using through all of this is watts equal voltage times amperage. That's my basic equation. W equals V times A, and I can use this equation to solve for volts, which would be volts equals watts divided by A, or I can solve for amperes, which is A equals watts divided by voltage. So this is my equation here that I'm using throughout. So now let's start. We're looking at 740 watt hours. Now I have, again, going back to my equipment, I got two, for now, 100 watt solar panels. I may add additional panels in the future, but right now I have 100 watt solar panel and another 100 watt solar panel. Now these panels are going to be connected in parallel, so I'm going to end up with plus, plus, minus, minus. My plus is going to be, and my minus is going to be, so those are my connections. The solar panels, the solar panels are Renogy solar panels, and they have a rating of 17.9 volts and 5.72 amps. 7.9 volts times 5.72 amps equal 98.4 watts. Remember my equation. Volts times amps equal watts. Volts times amps equals watts. Now this is per panel. I have two panels. So 2 times 98.4 is 196.8 watts. So if I take my watts divided by voltage, which is 12 volts, these are rated at 12 volts, 12 volts. So if I take 196.8 watts and divide that by 12 volts, which again, my panels are mounted in series, so my voltage stays the same. So I have 12 volts here. That gives me an amperage of 16.4 amps. So this 16.4 amps is rating, would have to be under the rating of my charger controller. And the one I have from Renogy is rated at 30 amps. So this tells me that the charger that they provided me is adequate for two of these, and if I can stretch this, I can go to 2 panels work, 3 panels work, and maybe it's questionable, even though they say you can connect 4 panels to this, it's still questionable whether 4 panels of their 100 watt 1200 volt solar panels would work. So that's questionable right there. So this tells me with my current controller, the 2 panels that I have currently will work. I definitely can add a 3rd panel with no problem, and I have to just do some more checking as far as going to a 4th panel. So as we have it right now, connecting to my controller are positive and minus connections, which are, so I have my 100 watt and 100 watt solar panel going to my 30 amp rated charger controller. Coming off of this will be my battery. My batteries are 12-volt batteries with a amp hour rating of roughly 100 amp hours. 12 volts at 100 amp hours. 12 volts at 100 amp hours. These batteries also are connected in parallel. So adding up these three, I come up with 100 amp hours plus 100 amp hours plus 100 amp hours equals 300 amp hours. So if I take 300 amp hours times voltage, which is 12 volts, remember A times V equals, since I'm carrying the hours, this becomes hours and watt hours. So this equals 4,800 watt hours. Checking my math, 300 times 12, 3,600. 3,600 watt hours. Now the rule for batteries, which is a lead acid battery, you can only charge down to 50%, which means my 3,600 amp hours is my full rating, but in reality I can only use 3,600 divided by, or times 2 times 50%. That equals 1,800 watt hours. So that's my number there. I can only use 1,800 watt hours. So with my three 12-volt batteries rated at 100 amp hours, my actual work out of those batteries, it's 3,600 amp hours divided by charging down to 50% is only 1,800 amp hours. Now the question becomes, how long does it take for my solar panels to charge my three batteries? And this is just simple math again. We're going to take 1,800 watt hours and divide that by, and let's just round this off. We're just going to round this off. Focus. 1,800 watt hours divided by the 196 watts over here. This equals 9.14 hours. So what this is saying that based on my loads that I calculated of my LED light, my LED TV requires 740 watt hours for a duration of 4 hours that I'm assuming I'm going to be in my workshop. I'm going to come up with two solar panels that can produce 196.8 watts. My battery capacity will be half of the rating, which is 3,600 watt hours divided by a half equals 1,800 watt hours. That divided by the watts that's generated by my solar panels, which is 196.8, gives me 1.14 hours. That's saying that it takes 1.4 hours for my battery to go from half charged to full charge. That duration is equal to 9.14 hours, which really isn't bad for me because I'm only going to be in the shop roughly 4 hours, and it's not going to be 4 hours every day. It's 4 hours on a casual basis. And then there are going to be a lot of days that I'm not going to be out here. Sun is going to be shining or partially shining, so that within those 9 hours I can get a full charge. Now keep in mind, I did mention that I'm considering adding a automatic transfer switch to the system here. And what that would what that would do is that it will allow me to continue to power my LED lights and my LED TV either from my power inverter off my solar system or from my house current. So also I have an inverter, and I didn't mention that, but my inverter feeds my loads, which consist of LED lights and LED TV, as well as some minor plug-in and plug-out miscellaneous items. So going from my charger to my inverter, I have a line running, and also have a negative line running to the two. I need a fuse here, as well as a fuse here. Fuse between the controller and the inverter is basically 1.5 times the rating of my charger. So my charger is 30 amps, so my fuse would be 30 times 1.25. That would equal a fuse with a rating of 40 amps. The fuse that came with the kit for the 2 solar panels is a 30 amp fuse, and that goes in this area here. So now we got a fuse between the solar panel and the charger, a fuse between the charger and the inverter, and now we need a fuse between the battery and the charger. You got to remember, and I didn't show it here, is that I have 3 connections. I have 2 connections for my solar, 2 connections for my inverter, but also these connections are shared going to my battery, and this one is shared going to my battery, which are up here. These connections here are the same as these connections here and here. So between these 2 points here, I'm going to end up with another fuse, and that fuse is going to be rated at 175 amps. So to summarize here, what I have is I have 2 100-watt solar panels, 2 100-watt solar panels, as in here, feeding my charger controller down here. My charge controller feeds both my inverter as well as my batteries, and I know that based on my loads that I calculated here, which was 160 watts for my 8 tubes of 20-watt rated LED lights, shop lights, 1 LED TV that's going to require 25 watts of power, running for 4 hours, which gives me 740 watt hours. The panels are rated at 17.9 volts at 5.72 amps. That gives me per panel an output of roughly 98.4 watts times 2 panels, which gives me a total wattage output of 196.8. The 196.8 divided by 12 volts, because these are rated at 12 volts, gives me an output of 16.4 amps going to my controller. My controller is rated at 30 amps, so based on that, I can easily power 2 solar panels. In the future, I can add a third, and questionably, maybe add a 4th panel based on the ratings. Along with that, I go to an inverter and my battery pack. My battery off my charger requires a fuse of roughly 175 amps to protect this. And then I know that a fuse going from my charger to my inverter is going to be 40 amps, which is 30 amps times 1.25. As a factor, it gives me a 40 amp fuse. I also know that with 300 amp hours, I can only use half of that, which is a 50% factor, so that changes out to 3,600 watt hours divided by 2, which gives me an actual available power of 1,800 watt hours. 1,800 watt hours divided by my output from my control, my solar panels of 196.8 gives me a duration of 9.14 hours to recharge my batteries at half load. From half percent power back to 100% power is going to take 9.14 hours, which is fine because I don't require this to be on a routine basis. This is on a casual basis, so some days I may use it and other days it just may sit here and generate power and charge up. In addition, as I mentioned, that I'm going to consider an automatic transfer switch to be able to transfer between my solar power inverter and my house current.